Welcome to this tutorial on multi-cluster service mesh with Istio. In this video, we'll explore how Istio enables service mesh functionality across multiple Kubernetes clusters, allowing services to communicate seamlessly across cluster boundaries while maintaining consistent security and observability. A multi-cluster service mesh extends the capabilities of a service mesh across multiple Kubernetes clusters. It enables unified traffic management, security, and observability. Services can communicate across cluster boundaries seamlessly, as if they were in the same cluster. Consistent security policies are applied across all clusters, ensuring uniform protection. Additionally, centralized observability and control plane management provide a single pane of glass for monitoring and controlling the entire mesh. There are several compelling reasons to adopt a multi-cluster architecture. High availability is achieved by distributing workloads across regions for disaster recovery and failover capabilities. Isolation allows you to separate environments such as development, staging, and production while maintaining connectivity between them. Locality-based routing enables traffic to be routed to geographically closer services, resulting in better performance and lower latency. Finally, scale becomes easier as you can overcome single cluster limits by distributing workloads across multiple clusters. Istio supports several deployment models for multi-cluster setups. In the multi-primary model, each cluster has its own control plane called Istio, and services can be accessed from any cluster in the mesh. The primary remote model features one cluster with the control plane, called the primary, while remote clusters connect to it for configuration without running their own control plane. Additionally, clusters can share the same network, where pod IP addresses are directly routable, or use different networks, where east-west gateways are required for cross-cluster communication. In the multi-primary model on a shared network, each cluster runs its own control plane. This architecture allows direct pod-to-pod communication across clusters without any intermediary. The independent control planes increase resilience, as the failure of one control plane doesn't affect other clusters. Because pods can communicate directly using their IP addresses, no east-west gateway is required, simplifying the architecture and reducing latency. When clusters are on different networks, the multi-primary model requires east-west gateways. Each cluster still has its own control plane for resilience. East-west gateways are deployed to route cross-cluster traffic, as pod IP addresses are not directly routable between clusters. This configuration works across isolated networks and different cloud providers, making it ideal for hybrid and multi-cloud deployments. The gateways handle all inter-cluster service communication. The primary remote model uses a centralized approach where a single control plane in the primary cluster manages all clusters in the mesh. Remote clusters do not run their own control plane, which results in lower resource overhead. The primary cluster's Istio provides configuration to all remote clusters. While this reduces operational complexity and cost, it's important to note that the primary cluster becomes a single point of failure. If the primary control plane goes down, configuration updates cannot be pushed to remote clusters. Istio automatically discovers services in all connected clusters and makes them available mesh-wide. Service entry resources are used to expose services from remote clusters as local endpoints within each cluster. DNS resolution works transparently, resolving services to endpoints across all clusters in the mesh. Load balancing then distributes traffic across service instances in multiple clusters, ensuring optimal resource utilization and improved availability. Multi-cluster service mesh provides powerful traffic management features. Locality-based routing allows you to prefer services in the same cluster or region for lower latency and better performance. Cross-cluster failover automatically routes traffic to healthy instances in other clusters when local instances fail. Traffic splitting gives you fine-grained control over the percentage of traffic sent to each cluster, useful for canary deployments and gradual migrations. Finally, mutual TLS between clusters ensures encrypted communication with mutual authentication, protecting data in transit across cluster boundaries. When implementing multi-cluster service mesh, several key considerations must be addressed. Network connectivity is crucial. You must ensure either pod-to-pod connectivity or deploy east-west gateways for clusters on different networks. Trust domain and certificates need to be configured with shared trust for mutual TLS to work across clusters. Balance the complexity versus resilience trade-off. Consider the operational overhead against your high availability requirements. Finally, implement unified observability to collect metrics and tracing data across all clusters, providing comprehensive visibility into the entire mesh.
If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.